this area thing is actually going to be useful to us because if the function is nice enough, you can use that to calculate an integral. That's what we're going to do here. We're going to evaluate a definite integral. So we're taking the integral from 1 to 5 of the function x plus 4 dx, so with respect to x. Okay, so this in here, x plus 4, that is our integrand, thing that is being integrated. That's our f of x. Our a value is 1, our b value is 5. Those are our limits of integration. And yeah, we're doing things with respect to x, so that just kind of checks. Okay, that variable matches this variable right here. All right, we're good to go. We don't end up doing too much with that in this class. All right, so how we're going to do this is we are going to use area. So we're going to plot this function real quick. Okay, and I'm going to see like how big my y values are going to get here. We're going to need to ultimately go from x equals 1, so that'd be a y value of 5, to an x value of 5, and that'd be a y value of 9. Okay. 1, 2, 3, 4. Okay. Okay. All right. So yeah, I'm going to plot this thing here. Here's 1, 5, and this is a nice line with a slope of 1, intercept of 4. All right. And we want to go 2, 3, 4, 5. That would have a y value of 9. Super fun graphing, good times. Okay. So yeah, our function here would be this line. Okay. And so to find the integral here, we're going to use the area between f of x and the x-axis. Okay, now here, going from 1 to 5, this function has been set up kind of nicely that on this one, we don't have to worry about net area. There is no area below the x-axis in this case, so we don't have to think about negatives quite yet. We'll get there though. All right, so we can do our approach like we did at the start of section 5.1 to this particular function. We can split this up into a rectangle and a triangle, okay, and then add the two together. So area of the rectangle would be width times height. That would be 4 units wide times 5 units high. So we'd get 20 square units there. Okay, so this part in here is 20. And that is positive 20, just to reiterate. And then for our triangle, we would do 1/2 base times height. So base is 4. And the height on that thing, that goes from 5 to 9. So the height is also 4. And we end up getting 8 square units there. So this up here has an area of 8. And then we add them together. So the total area underneath there is 28 square units. And so that turns out to be the value of this definite integral. So the integral from 1 to 5 of x plus 4 with respect to x equals 28. Okay. So yeah, that is just using this idea right up, this idea right up here. There we go. The area can be found by taking the definite integral, or the definite integral can be found by finding the area. Okay, so that's what we just did. We calculated the integral by finding the area between the curve and the x-axis.